Hello all of you, we will start a topic that is a stack. We all know that stacks is a linear data structure. Now what is linear data structure? Linear means where we can access the data one after the another. And what is stack? Nothing but a stack of memories. Okay, for example, we can say a stack of books. See, this we can say this is a stack of books. Now we know that stack is a LIFO structure. What do you mean by LIFO? That is last in and first out. What is that? In case of a stack, that is one end is a closed end, the another end is open. That if you want to insert or delete any element in the stack, then we have to do from the one end. Okay, so suppose this is a stack which is closed from one side. If you want to store any element over here, first suppose we are storing this, next this one, next this one. Now suppose we want to remove their element. So since the one portion is the close, only we have one position, that is from the top, we have to remove the element from the top of the stack. So the element, or in this case suppose the book which I have stored at the last, will be the first one to be removed. See, next the one that is which I have stored in the second last position, I have to remove this. This way the element which is stored in the stack at the last is removed at the first. So we say that stack is a LIFO structure, that is last in and first out. We all know that in order to store an elements or any values in the memory, we have to locate that memory address location. Now for locating that address location, in case of a stack, we use a pointer which is known as a top. Top will show us the location where the element had to be stored and from where the element has to be removed. So in case of a stack, we do a two operation. There are two operations in the stack. Stack has two operations. Number one, inserting an element, insert an element. And number two, delete an element. Now to insert any element, we use the term that is push, and to delete an element we use a term that is pop. Now take an example. Suppose we are taking an example. We want to insert the items, that is A, B, C and D. So initially we have to declare a memory of stack, and we have to know the maximum size of the stack, which is denoted suppose by a variable that is max size. We have to know this maximum size of the stack. Suppose the maximum size of the stack is 5. See, 1, 2, 3, 4, and this is 5. Initially we can see that this stack is empty, right? So we will insert a value one after the another. Now Now we have discussed that to access any element or to insert any element, we use a term, or we use a pointer, rather this is known as a pointer. We use a pointer that is known as a top. Now initially we also have to know that the maximum size of the stack. When the stack is empty, that is we can see there is no element in the stack, the value of a top is equals to, the value of top is equals to 0. Some book it is known as, we use a 0, or we can also use -1. When the top is equals to 0, that means the stack is empty. Now suppose we want to insert an element, that is suppose A. Now in order to insert this element A, we have to take the top to the position 1. So we have to increase the value of top equals to 1. Like we increase the value of top to the next higher level, that is top equals to 1, and then we store the value A over here. Suppose we want to store the next element, that is B, we have to increase the value of top, that is now the value of top is equals to 2, and then we store the value B. Again we have to store the element C, then we have to increase the value equals to 3, and then we insert the element C. Like this way we keep on inserting the element until we reach the max size. Once we reach the max size, there is no space in the stack, so we cannot insert any element in the stack. This was an example of a push operation, that how to insert an element in the stack. Now let us see example, that is for pop. Pop means to delete, that is we have to delete an element. This is our stack, this is the last stack we have drawn. We know this is A, B and C. Now here is our top, and the value of top is 3. Okay. So the first thing we have to do is to remove any element. Is we know, since the stack is a LIFO structure, that is a LIFO structure, the last element which is inserted, we know, we have seen it is a C. So we have to first remove the element C. That is the last element is the one which is deleted first, or the first one, that is the last element is the one which will go first out. So we will delete the element, that is first we will delete the top element of the stack. Now the top element is C. Once we delete the top element, now the stack look like this, that is A and B, and our pointer is over here. So we have to decrement the value of top to the next lower position, that is here. So now the value of top is equals to 2. So in case of a push operation, the first thing we have to check is whether the stack is equals to max size or not. If it is equals to max size, we cannot insert any more elements in the stack. Then we will increase the value of top by 1, and then we will insert the element in the stack of top. In case of a delete, we have to check whether the stack is empty or not. Now for checking whether the stack is equals to empty or not, if the value of top is equals to 0, then the stack is, we know, empty. So we cannot delete any element from the stack, since there is no element present. If the stack is not empty, that if the stack look like this, then we have to first remove the element, and then we have to then decrease the value of top by 1. That is now the value of top equals to 2. In case of the stack, we know that we have to deal with the two operations, that is push and pop. So we will do a two algorithm. One is for inserting and another for deletion. So let's check. That is push operation. In case of a push operation, what are the things we are requiring? This is the algorithm. We require stack. We require max size. We have to know the max size of the stack. value of the top and the item which is to be inserted, or it is also known as the element to be inserted. We have discussed previously that first we have to check whether the stack is empty. The stack is have reached to the max size or not. So we know by using the pointer value top, if top is equals to max size. Now double equals to mean comparison. We compare the value of the top with the maximum size which we have declared before we are using the stack. If it is equals to max size, that means we cannot insert any more element in the stack. So we write printf stack is full, or we can also write stack is overflow. Since we cannot insert any element, we have to exit from the stack. Step 2, that is, if the top is not equals to max size, that is the else part, what we have done? We have increased the value of top equals to top plus 1, and in step 3 we have insert that item in that position, that is stack of top. That stack of top is equals to item. And step 4 is if you see the example, suppose here the max size is 3. We first check the value of the top, and we all know the top will point to the top position of the stack, and the value of the top is 3. So top is equals to 3 and max size equals to 3. So the stack is full, so we cannot insert any element. This is the condition 1 or the scenario 1. Otherwise, if other scenario exists, that is, suppose there are some element present in the stack and the max size equals to 5, and we want to insert an element, that is C, D and E. Now the top is pointing over here, that is at position 2. We have first checked that the value of the top is equals to 2, which is not equals to max size. So we will go to the else part. Here you have to increase the value of top by 1, that is top equals to top plus 1. So now the value of top is equals to 3. Now stack of top, what is the value of top? That is 3. Stack of 3 equals to item. What is that item? That is equals to C. So at this position we will insert a value C. Next, if we want to insert the element D, first again we have to increase the value of top. Now the value of top is equals to 4, and at this position 4 we will insert the element, that is D. This is how we can insert an element until there is space in the stack. Hope this push operation is clear to you all. Now let us check another algorithm, that is pop. Now pop means to delete. Now to delete, we require a stack, we require top, and we require item. Here we don't require the max size because we don't need to know the value of max size for deleting any element. Now first step, that is step 1, is that to insert any element, we have checked the value of top is equals to max size or not, then we cannot insert it. And in case of a deletion, we have to check whether there is any element present in the stack or not. So if the top value is equals to 0, it means the stack is empty or the underflow. So we cannot insert any, we cannot delete any element from the stack. So we check if top is equals to 0, printf stack is empty. We can also use the term underflow. And we insert. Else, if there is element in the stack, if there is element in this stack, what we have to do is we take a variable that is item, where we will put the top element of this stack, and then we will put that element in the variable or store that element in the variable that is A. We know we have done in the C that when we write A equals to 5, it means that the 5 is stored in the variable A. Similarly, the value of stack of top will be stored in the variable item. Step 3 we know we have done, that is we have decreased the value of top equals to top minus 1, and step 4 is exit. Now let's see scenario 1. Suppose this is the top. Now here the value of top equals to 0. So we can see here there is no element, so we cannot delete anything. So this is the first scenario, that is if part, else part. Suppose we have element A, B and C, and we know this is the top value, that is top equals to 3. Now we always know that to remove or to delete any element, always the top value of the stack will be removed first. So we will remove C and we will store in the variable that is item. So the value of item is now equals to C. After removing the C from the top 3, we have to decrease the value of top to top equals to 2. So now the stack will look like this, that is A and B. Now the top will be pointing over here, that is top equals to 2. Now suppose again we want to delete any item, again we will store the value of B in item, that is item equals to B. Now we have to decrease the value of top, that is top equals to 1. This is how we delete an element from the stack. These are the two operations or the two algorithms which are very important for this stack, that is one is push and another one is a pop. Hope this is clear to you. If you have any queries or any difficulties, do comment in the comment section for any queries. Thank you.